Hello children, we are on the lesson carbon compounds and we are starting with the introduction part of it. Class 10th chemistry. Carbon has atomic number 6. The protons are 6, the electrons are 6. Now when we represent carbon in a simple form, it is represented as 612, where 6 is the atomic number and 12 is the mass number. Although we know there are the other isotopes of it also, but now we are studying about carbon 6. Mass number, we know that is equal to proton plus neutron, and proton is also known as the atomic number, and N represents the neutron. So the electronic configuration for carbon is written as Kl, the shell names, 2, 4. The center part is representing the nucleus. The first shell and the second shell are having the 2 electrons and the 4 electrons each. Now, one very important thing is carbon is called tetravalent in nature. The presence of 4 electrons and how it is combining with the other to form the bonds. This is the tetravalent nature of it. In the previous lesson, we have done that the metals have the capacity to lose the electron. That is 1, 2 or 3 electron they can lose. They undergoes oxidation. While the non-metals are having the tendency to gain the electron. The non-metal which is having the 5 electron can gain 3 electrons. The one which is having the 6 electron can gain 2 electron, and the non-metal which is having 7 electrons can gain 1 electron. But loss and gain results in development of the ionic bond. This is the ionic bond formation. But in case of carbon, if we are talking about, there is presence of 4 electrons in the outermost shell, but carbon cannot lose the 4 electron, neither it can gain 4 electron to become a duplet or the octet. The loss of electron to become a duplet or the gain of electron to become the octet is a very difficult task. And why it is very difficult becomes a very important question. So let us start with some of the very key points here, that why C positive 4 and C with the power -4 is not possible. So the first thing, carbon cannot become 4 negative. Carbon cannot become 4 negative ion, or it cannot gain 4 electrons to attain 4 negative ion to attain the configuration of neon, that is 2, 6, that is 2, 8, that is the configuration of neon. It cannot become like this. Why carbon cannot exist as C4 negative ion or anion? Because this anion, very important line, this anion would be highly unstable. This is going to be highly unstable in nature. The 4 electrons, gain of 4 electrons make it highly unstable due to large amount of energy required to overcome. The incoming 4 electron will result in making a repulsion with the pre-existing electrons due to large amount of energy which is required to overcome the force that is developing in between the incoming electron and the existing electron, overcome the force of repulsion between the 4 electrons which are added, between 4 electrons being added and the 6 electrons already present. 6 are present before in also, and 6 electrons already present. So this type of repulsion, overcoming of this repulsion is very difficult, and C4 negative ion or this anion cannot be made stable. Now the other thing, why C4 positive cannot be formed? Why it cannot become a duplet like the helium? So the another board related thing is C4 positive ion cannot exist. This can also not be possible. C4 ion cannot be made possible, that is equivalent to helium, or if it loses the 4 electron, carbon as having 6, 2, 4, if it loses these 4 electron, it will become like helium. But this thing is also not possible because again in this case, the cation would be highly unstable in nature. The cation that is C4 positive. The C4 positive would be highly unstable in nature. Unstable in nature due to the large amount of energy, due to the large amount of energy which is required to remove these 4 electrons. Required to remove these 4 electrons. So in both the cases, neither the gain is easier nor the loss is possible. So carbon is not able to attain the helium-like configuration. Neither the carbon is able to attain the C4 negative, that is the neon-like configuration. So what should carbon do to attain a stable configuration? It cannot undergo formation of cation or anion. So what the thing it has found to be done, that the carbon undergoes sharing of electrons. The third concept, if loss is not possible, gain is not possible, then carbon tries to do the sharing of electrons, resulting in formation of a new term that is known as covalent bond. So first of all, we will be going through what is covalent bond, how it is defined. Then we will be carrying on with the various examples of it. So a chemical bond which is formed between the two atoms by the mutual sharing. Remember this word, that there is a mutual sharing. When a chemical bond or the force is developed by the mutual sharing of the valence electron, the outermost electron, between the two atoms in such a way that each atom acquires the stable electronic configuration or nearest noble gas configuration, then such a bond is known as covalent bond. Remember this word, students, that covalent bond is formed by the sharing of electron, while ionic bond is formed by the loss and gain of electron. Ionic bond is between the metal and non-metal, but the covalent bond by the sharing of electrons. So the number of electrons that are shared is known as its covalency. If one electron is shared by each, then the covalency is 1. So the number of electrons shared. Now in case of carbon, there are the 4 electrons. And carbon is going to attain the stable configuration by sharing all these 4 electrons. Because it cannot lose 4, it cannot gain 4. So carbon is undergoing the sharing part. Since carbon is sharing all the 4 electrons, that is why carbon is known as tetravalent in nature. And those compounds in which sharing of electrons is done, such compounds are known as covalent compounds. So a very, very small topic. What are covalent compounds? Which are formed by sharing of electrons. And what about carbon? Carbon is having 4 electrons in the valence shell. Carbon cannot lose 4. Carbon cannot gain 4. So carbon is undergoing the sharing phenomena now. Now let us see how the structure and the nature is described. Carbon is tetrahedral in nature. So how the 4 electrons are getting the geometry, it is known as tetrahedral. And since it is undergoing the 4 electrons sharing, it is called tetravalent. The 4 electrons in the L shell. The 4 valence electron, in order to achieve the noble gas configuration, undergoes the mutual sharing with the other carbon or with the other element. It undergoes the mutual sharing. And due to the mutual sharing and formation of these bonds, the carbon is known as tetravalent. This is also very important thing. Why carbon is called tetravalent? Because it undergoes the formation of noble gas configuration by the involvement of the 4 valence electrons due to the mutual sharing. The 4 valencies of carbon do not lie in the same plane. Remember this, that all the 4 bonds are not in the same plane, but they are lie in one plane and some are directly shown in a tetrahedral form. Look at the structure of carbon, how the 4 electrons and the bonding is arranged. This type of arrangement is known as a tetrahedral arrangement. This is a proper representation of carbon in the space. One of the bond that you are going to see as the dotted bond is considered as the bond which is away from the observer. If the carbon is considered in a 3 dimension, that is the space, then the bond which is away from the observer is represented as a dotted bond, and the one which is towards the observer is represented as a thick line or a thick bond. So carbon is undergoing shearing. The mutual shearing results in formation of a covalent bond. And now, how many types of covalent bonds are there? But before going in the detail of how many types of covalent bond are there, let us do some simple, very simple examples of covalent bonds. Then we will go with types of bonds also. Now let us see one example, that hydrogen wants to have 2 electrons in its first shell, but hydrogen is having only 1 electron. So one of the method is that the hydrogen can gain 1 electron from any other element, or the other thing is hydrogen can share 1 electron with any other atom or element that also needs 1 electron. So hydrogen, let us consider the example of hydrogen molecule. Hydrogen 1 electron with another hydrogen 1 electron undergoes shearing. Look at the shearing part, that in both the cases there is a 1 electron of 1 hydrogen and the other electron of 1 hydrogen. But when we are going to draw the circle, both the electrons are considered a part of each. Such a shearing, mutual shearing, fulfilling the nature of both of these, making them the stable in nature, is known as a covalent bond. That is, mutual sharing is there. So before it, represent hydrogen as an electron dot. This is known as the Lewis representation. Now the similar thing we can see in case of HCl. Then we will go in the detail of types of bonds also. But a very simple case, hydrogen is having only 1 electron, and there is chlorine which is having 17, that is 2 its 7. Cl wants to become stable. So it wants either an element can give it a 1 electron, so it becomes 8, or by sharing also it can become 8. Hydrogen is having only 1 electron. It cannot lose its 1 electron. Otherwise it would become 0. Hydrogen also wants to have duplet. Chlorine also wants to have octet. So what the two do, what the thing that you find is, hydrogen puts 1 electron in the center, chlorine puts its 1 electron in the center, and there is a mutual sharing in between both of these. So sharing of a single pair, that is 1 electron of H and 1 electron of Cl, is represented by a single line, and this is known as mutual sharing of electrons or a covalent bond. So in today's video, you have learned how a covalent bond is formed. In the next one, we will be doing the types of covalent bond. Till then, revise this topic. Have a nice day.